Hello and welcome to this video on naming acids and bases. So in order to have a good understanding of nomenclature as a whole, we need to include acids and bases in with our ionic compounds and our covalent molecules. And so first thing that we need to know is what is an acid. So an acid is where in solution, and so I should write this up here, in solution, okay, maybe I'll do it this way. In solution, they are going to have a greater concentration of hydrogen ions versus hydroxide ions. And so this bracket that we see here is representing concentration. Okay, so bracket equals concentration. A base then is actually the opposite of that, where the concentration of hydroxide ions is greater than that of the hydrogen ions. And so we have a little diagram here. Let me see what this looks like. And so on the left-hand side, we see that this is an acid. There's more hydrogens than there are hydroxides, and then on the right hand side this would be representative of a base, and so this is just a way of modeling that. And we also have this pH scale which helps us to be able to measure this. And so with the pH scale, it's a logarithmic scale and it's looking specifically at hydrogen, okay, ion concentrations. And so if it has a low pH, that's an acid. If it has a high pH, that's a base. And then in the middle of those, it is neutral, and so 7 would be neutral. We come back later in the year and we focus a little more on acids, bases, and pH as far as the chemistry that happens there. But right now what we want to do is focus on the nomenclature, how to name these things. So let's take a look at naming acids with a single nonmetal anion. And so what we want to do is we want to have the hydro as the prefix. We want to have the anion root in the middle and ic as the suffix, and then we put acid at the end. Okay, and the "ide" that you normally see in your anions becomes ic when we are doing these. Okay, it's just so you know. So we're going to take that base of our names and we're going to write it as ic. So I'm going to give you a couple of examples. So a couple of common examples. HCl is a very common example, and HCl is hydrochloric acid. Okay. Another one that we could see would be H2S, and this one would be hydrosulfuric acid. Now, the challenge becomes there's some similarities in some of these names. Or maybe we have, HI, okay, hydroiodic acid. Okay. And what you notice in these is that each one of them has hydro at the beginning, so hydro. Then we have the root of the name, so hydro in each one. We have the root, okay, chlor, sulfur, and iod. And then at the end, of course, we have ic. Okay, so that's the breakdown of how we write these acid names, or how we say these acid names, with single nonmetal anions. Please notice that the thing that makes them an acid is the fact that each one of these is starting with hydrogen. Okay, if you see hydrogen at the very beginning of the element, a lot of those are acids. Now there's a couple exceptions. H2O, which honestly, we could have further discussion about that. We will later in the year. And then H2O2. But other than that, if you see an H at the very beginning of your compound or formula, then that would be indicative of having an acid. So just to make sure you guys are really good on those roots, you can always go back and look at the periodic table of ions because it is helpful there. But when we're looking at the root words for these, for nitrogen it would be okay, so nitric would be the acid. Fluor, fluoric, chlor, phosphor, and of course we saw this one already as well, iod. And so they look different depending upon what they are, and we just get used to these. So if you have any questions about that, be sure to let me know so that I can help you and assist you with determining those. We just get used to them over time. Okay, so now we want to switch and we want to look at acids with polyatomic anions in them versus the single anion, and the naming system for this is a little bit different. So with the polyatomic anion, we're going to have the polyatomic anion root and then ic, or, and this should be us, O-U-S, okay, acid. So if the polyatomic ion ends in ate, A-T-E, it becomes ic, okay? If the polyatomic anion ends in ite, it becomes us, O-U-S, and we're going to kind of keep it to this. There are some additional things that we could talk about with those polyatomic ions. We're going to keep it to the ate ic, ite us, and I think if I ate it, it could be icky, and an itis is an ailment. Okay, so I kind of try to do some word associations there. So here's an example. Okay, say we have H2SO4. This would be sulfur because the SO4 is sulfate. Okay, so SO4 is sulfate. So it becomes sulfuric acid. Now please notice that that's different from the H2S that we saw that was hydrosulfuric acid. That only had the sulfide, the individual S, as an anion, and this has the polyatomic ion. And that's usually where people get the most confused. Okay. Let's take a look at one that has both an 8 and an I. I'm going to give you a different example. And so we could have something like HNO2 versus HNO3. Okay, for HNO2, that is nitrite. So that is nitrous acid. And HNO3 is nitric acid. Okay. Not every one of those polyatomic ions that we see on there are ones that we encountered throughout the year in our chemistry experience. Actually, sulfuric and hydrochloric and nitric acid are probably the three ones that are very common for us to be using in the chemistry lab. All right, so now what we want to do is take a look at how to name bases. So that's how to name acids. So how do we name a base? Well, honestly, it's just using ionic naming systems. And so it's an ionic bond between the cation and hydroxide. So anytime you see hydroxide, that's a strong base. We'll talk about weak bases later in the year, and we're going to use that same system of naming as we did when we had just ionic compounds. And so say we had something like sodium hydroxide, NaOH, it's just sodium for the metal, and then hydroxide. Okay, that's the anion. Or say we had calcium hydroxide, CaOH2 for the formula. We use the same way of doing that formula as we did for ionic compounds. And so that one's going to be calcium hydroxide. Okay. Every single one of these is just going to be a metal hydroxide. And those are usually pretty easy, and then like I said, we've already encountered that with our ionic compound names. I hope that was helpful for you, and we will take a look at these further in class.